So in the last lecture we were discussing about the visualization of these operations. So we discussed about this union, right, and this intersection which gives me the common area between set A and set B. And now let us talk about this diagram. This now B union C, and then we will take its intersection with A. So I require common area between set A and B union C. B union C will involve these two circles, right? So the complete area of these two circles, but I need these areas to be common with A. Like I need the common area between A and B union C. So the only common area or the solution area will be this common area of A and B and C. Okay, so this will be the solution. And if I need A intersection C, I need common area between A and C. So this will be the required area. So this is how easy it is to visualize these operations using Venn diagrams. Now let us see this A intersection B. So A intersection B will give me this common area, and I need to take union with A intersection C, which is this common area. So I require this as well as this because I need to take union, right? So this is the area. Now if you notice this diagram and this diagram, these are giving me the same answer or the same area, right? Why? If you notice these two expressions or operations, you will see that this is intersection and it can be distributed over union, right? So this is the distributed version of this only, right? A intersection B union A intersection C. So it has to give me the same area. Now the only thing is left in introduction part, difference of sets. Difference of sets. If I am looking for difference of sets A and B, I'll write it as A minus B. Okay, and there is another difference B minus A. These two are different, right? They do not convey the same meaning. What is difference of sets? If I want to write A minus B, so it means, now this expression here A minus B means all the elements of A that are not there in B, right? And by your simple logic you can find the meaning of B minus A, that all the elements of B that are not there in A. So obviously these two expressions will have nothing in common, right? Because let me write two sets A and B for you, and then you'll be able to visualize it much better. 1 2 3 4 5, and let us say B is 4 5 6 7 8. Okay, now if I want to write A minus B, A minus B, I want all the elements that are there in A but not in B. So can I take 1? Yes, because 1 is there in A but not in B. So obviously 1 will come here. 2, it is obviously in A and not in B, so it is also acceptable. What about 3? 3 is there in A but there is in A but not in B, so it is also acceptable. 4 is there in A but it is also present in B, so 4 will not be taken. 5 is present in A but it is also present in B, so that will also not be taken. Hence this is my answer for A minus B. What about B minus A? Now I need all the elements that are there in B but not in A. So can I take 4? If I take 4, it is very well there in B but it is also there in A, so 4 cannot be taken. 5 is there in B but it is also there in A, so it will not be taken. What about 6? 6 is there in A but it is not in, 6 is there in B but see, 6 should be there in B and not in A, so 6 satisfies the condition. 7 is there in B but not in A, so it is okay. 8 is there in B but not in A, so this is my answer for B minus A. If you now notice, there is nothing common between A minus B and B minus A, and it is obvious from the definition itself that there will be nothing in common. between them. So if I ask you, let us say, if I take intersection of a minus b and b minus a, what will be it? It will be an empty set. And if you want to visualize from the Venn diagram, let us say this is set A and this is, let us say, set B. This is A, this is B. So what will be A minus B? What will be A minus B? The elements of A that are not there in B. So only these elements, right? I cannot take this common area. This common area cannot be taken. Which common area? This common area, this one, will not be there in A minus B, because this common area belongs to both A and B, right? But I need only the elements that are there in A and not in B. So the area that I've shaded in red is the area that gives me A minus B. Okay, and obviously you know what this area gives me, common area, that is in green. This area is obviously A intersection B, the common area to both of these sets. Now what is this area that is left? This area, what is this area? These are all the elements of B, all elements of B, but not of A, right? This yellow area gives me B minus A, B minus A, right? So there is nothing common between A minus B and B minus A, and then there is this common area between them which is in green, which is A intersection B. I hope you got the idea about A minus B, B minus A, and you already know about the intersection. Give me a moment. Another term that I want you to learn here is disjoint sets. Disjoint sets. As we spoke about A minus B and B minus A, we know that this is a set, right? This is a set. But was there anything common between these two sets? No, nothing was common in these two sets. So such sets which have nothing in common are known as disjoint sets. If I want to represent such sets using the Venn diagram, let us say this is set A and this is set B. So set A and set B have nothing in common, right? They do not intersect anywhere. So set A and B here in this diagram are disjoint sets. Disjoint sets. I can give you examples in terms of, I can write it them in roster form. Let us say set A containing elements 1, 2 and 3. Set B containing elements, let us say 4, 5 and 6. Now are these sets disjoint? Yes, these are disjoint sets. What about these sets? A minus B, A intersection B, B minus A. These sets are also disjoint sets because there is nothing in common in these three, right? Because this gives the common elements of A and B, but by the definition of difference of sets, I know I need the elements of A here and not of B. In this I need elements of B and not of A. So I'll avoid the common elements while taking the difference. That is why these three sets are disjoint sets. Okay, let us do some questions now. Let us look at this example here. If set A is this, set B is this one, I need to find the union A union B. So A union B, what is the easiest way to write a union? Let me write. I can write all the elements that are there in A, right? Now apart from these elements, the rest of the elements that are there in B will be written. 6 and 8 are already here in A, so I have already written them. Now 10 and 12. So by definition, we know that the element should either be present in A or it should be present in B. I need to write all these elements. So this is my A union B. Now if I want to write the intersection here itself, then what I need to write is the common elements in these two sets. So what are the common elements? We noticed that 6 and 8 are common to both the sets. So this will give me my intersection. Okay, now in this, set A is this, set B is this. We need to show that A union B is A itself. So obviously set B, if you can notice, is a subset of A, right? So I want to write the union, so I'll write all the elements of B and A, right? All the elements that are there in B or they are present in A. So when I write all the elements that are present in A, I will have already written all the elements of B, because every element of B is present in A, right? Because B is subset of A. If you see, B here is a subset of A. So if I take their union, that will be nothing but A. Or when you take union of two sets and one of the sets is subset of the other set, right? Then the superset or the bigger set will be your answer. Because once you write the bigger set, this set, you would have written all the elements in the subset, right? Because you don't have to write them again and again. So A union B is equal to A, or you can show them as like this: A union B is equal to X, such that X belongs to A or X belongs to B. Now, and what is that? X belongs to A, X belongs to B. So when I write X belongs to A, when I write all the elements of set A, I have already written these elements. Okay, I hope you have understood the idea. All right, so next one. And one more thing, that you can memorize this also. If there are two sets and you need to take union, okay, if one of them is a subset of the other, then the superset will be the answer. All right, now let us look at this question here. X, this set gives me these three names here, be the set of students of class 11th who are in school hockey team. And there is another set, Geeta, David and Ashok, be the set of students from class 11th, these were also from class 11, these are also from class 11, who are in school football team. Now I am looking for union of these sets, X union Y. So union Y, X union Y will give me Ram, Geeta and Akbar for sure. Ram, Geeta and Akbar. And what else? Geeta has already been covered, David and Ashok. So David and Ashok will also come in this union of sets, right? So X union Y is will have these names, Ram, Geeta, Akbar, David and Ashok. What is the meaning or interpretation of this set? That the players here in this set, X union Y, these are the players who play hockey. And see, now this is union of these, right? So I need elements that are there in hockey team or the football team. So when I want to interpret this, Ram, Akbar, Geeta, David and Ashok are the students of class 11th who play either hockey or football, right? They either play hockey or football. And as we can see, Geeta plays both hockey and football. This is also one of the interpretations. Akbar also plays hockey. No, Akbar is not common to both. So the interpretation is, this is the these are the names who play either hockey or football. And Geeta is one of them who plays hockey as well as football. Okay, we have already done this part, A intersection B, for example 12, right? We already took care of that. Example 14, if I want X intersection Y, we know that the player that plays both the games is Geeta. Geeta and Ram. Okay. No, let me check. Only Geeta. All right. So this is the intersection of X and Y. Right? We interpreted this union set as the players that play hockey or football. Now we will not take the repeated ones. Okay, we already know that. So you can interpret it like that also. The players who play hockey or football or both. But you do not have to write that because it is already covered in that, right? You know, while writing a set, you need not write the elements repeatedly. So it is enough for you to say that the players who play hockey or football, right? So that will be covered in that. This both will be covered in that also. Let us check the next question. This is set A, this is set B. I need to write A intersection B, and I need to show A intersection B is equal to B. Okay, so for that, I think B must be the subset of A, right? If B is subset of A, that means all the elements of B are there in A, right? So A is the superset. So when I take the common elements, all the elements of B will give me my answer. So let us check here. In set B, I have got 2, 3, 5, 7. And in set A, do I have all the elements of B? Yes, 2, 3, 5, 7. So what are the common elements? Obviously, all these elements are common to both of these. Now what I mean to say is B is a subset of A. So all the elements of B, all the elements of B, or you can say every element of B, every element of B is present in A, is present in A. So when I want the common elements, the answer will be B itself. So we have learned two things by now, that if A is, let us say, subset of B, right, and I want to take union of A and B, right, so the bigger set will be my answer. And if A is a subset of B and I want to take the common elements between A and B, this smaller set will be my answer. Or you can say that superset will be your answer in case of union, and subset will be your answer in case of intersection, and it is very obvious also, right? So next example, set A is this one, 1 2 3 4 5 6. Set B, we need to find A minus B. What is A minus B? I need all the elements of A that are not there in B. So 1 is there in A but not in B. 2, 4 and 6 are there in B, so these will not be taken. 3 and 5 are very well acceptable, so this is A minus B. What about B minus A? All the elements of B that are not there in A. 2, 4, 6, we have already seen that these elements are present in A also, so these will not be taken. 8 is an element that is present in B but not in A, so this will give me my B minus A. And as you can see, if I take their intersection, it will give me 5. Now this is V, that is set of vowels, and B set of A, I, K, U. V minus B. The elements that are present in V but not in B. So A is present in both, I will not take it. E, I'll take it. O, I'll take. Now see, I have not taken A because it is there in B also. I have not taken I have not taken U because it is present in both. Alright, and what about B minus V? The elements of B that are not there in A. A, I, U, we have seen that are common to both. So K is the only element of B that is not present in V. So B minus V is this, V minus B is this. Now find the union and intersection. Give me a moment. Find the union and intersection, because we will be required to find the intersection in question number 5. So I will find it here itself. Of each of the following pairs of sets. Now see, X in union Y will be, I'll write all the elements that are there in X and all the elements that are there in Y, barring the common elements. I will not write the common elements. So 1 I will not write, 3 I will not write, and 2 I'll write. So this is the union of X and Y. All right. Now if I want to write the intersection, I'll write only the elements that are common to both. So 1 and 3, if you see, are common to both x and y. So this is my x intersection y. All right. Now I've written 1, 3, 5, 2. If let us say in your book the answer is 1, 2, 3, 5, we already know that the order in which the elements are written does not matter. So this is also a correct answer. Or if you write these elements in any other order, that will be perfectly all right. This is set A, this is set B. So let me write union of A and B and intersection of A and B. So union of A and B will be A, E, I, O, U, and then A I have already written, B and C. So this is union. In intersection, I require only the common elements, which is A. A is common to both of these sets. Apart from A, there is no other element that is common. This is this curly bracket. Okay. Now in these two sets, if you see, A is a set of natural numbers which are multiples of 3, right? So if I want to show it to you, what kind of set is this? This is 3, 6, 9, 12, multiples of 3, and this is a natural number. X is a natural number that is less than 6. So this is the set 1, 2, 3, 4, 5, right? Now I need union of A and B and intersection of A and B. So union will consider all the elements that are present in A or B. So if you see, look at B, it has got lesser number of elements. So let me write the elements that are there in B first. 1, 2, 3, 4, 5. Now apart from these elements, all the elements that are there in set A will also be written. You know, 3 I have already written, so let me write from 6. So 6, 9, 12, 15, all these elements will be written. Okay, and I am not writing dot 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 because it will not give you the pattern that is required. Okay, because if you start from here, it is 1, 2, 3, so the first element should give you the pattern. Okay, so let me find another way. I cannot write it in roster form, so let me write it in, I hope you've got the idea that I'll have all the multiples of 3 as well as 1, 2, 4, 5 in that. Now let me write it in the set builder form. X is such that X is equal to 1, 2, 4, 5, or is a multiple of 3, is a multiple of 3, and I should also mention that X is a natural number. So now I've written it in set builder form, and it includes all the elements that are there in set A and there are in set B. Okay, so it was not possible for me to write it in roster form. Now let us look at the intersection. In intersection, I just need the common elements. So if you look at the natural numbers less than 6, these are the numbers, and out of these I just require the multiple of 3. So this is the only number that will be there in the intersection set. All right. Now look at this one. X is a natural number and X is less than equal 6 and greater than 1. So let me write X for you. X will be equal to 1 will not be there, right? It will start from 2, 3, 4, 5 and go up to 6. So these are the elements of set A, right? So this is my set A. This is set A. What is set B? It is again a set of natural numbers between 6 and 10. So this time between 6 and 10, that means 7, 8 and 9. 6 is not included, 10 is not included. Now if I want to take the union, I'll write 2, 3, 4, 5, 6, 7, 8, 9, right? And if I want to take the intersection, I'll write just the common elements, and you may notice that there is no element that is in common in these two, right? So the intersection will give me the empty set, and it is very well visible from here itself, because in the first set x is less than equal 6, and in the second set x is greater than 6. So there will be nothing in common. Okay, now let me take the union here. A union B will be A itself, because this is an empty set, so there will be nothing in it. So if I write 1, 2 and 3 here, it is enough. So this will give me intersection, and this will give me the union. And about intersection, there is nothing in common, so it will return phi. This we already know, that A union phi will give me A intersection phi will give me phi. Okay, let us move to the next question. Set A contains these two elements, set B contains these three elements. Is set A subset of B? Now, to answer this question, you need to ask yourself, is every element of A contained in B? Let us check. A, B, B. So yes, it is a subset of B. A is a subset of B. What is A union B? A union B. A union B contains elements that are there in A or B. Okay. So, and also we know that if A is a subset of B, the superset will be my union. Okay. If A and B are two sets such that A is a subset of B, what will be the union? Obviously B. Why? Because we just discussed it. Set A is this, set B, set C and set D. We need to find A union B. So for A union B, I'll write all the elements that are there in A or B. A union C, I'll write all the elements of A, and all the elements of C, just I need to avoid the repetition, which is not there, right? And B union C, so for B union C, let me write set B, elements of set B, 3, 4, 5, 6. Now I'll write elements of C, just avoid the repetition. So 5, 6 are already written, so I'll write 7, 8 here. So this is B union C. Let me write B union D. So I'll write all the elements of B, 3, 4, 5, 6, and then I'll write all the elements of D, avoiding the repetition bus. So I'll just avoid the repetition and write all the elements. So 7, 8, 9, 10. 7, 8, 9, 10. So this is the set B union D. Now what about A union B union C? So it will have all the elements that are there in A, that are there in B. So I have not written the common elements again, right? Because I have already written that. So it doesn't make sense in a set to write the elements repeatedly. So set C has got elements 5, 6, 7, 8. So 5, 6 we have already taken. So 7, 8 will be written here. So this is my set. And what about this sixth? A union B union D. A union B. So let me start with A. I'll write all the elements of A. Now I write all the elements of B, barring the repeated elements. So 3, 4 will not be written again, 5, 6. And then there will be elements of D. Just avoid the repetition, 7, 8, 9, 10. So there is nothing that is being repeated. So this is the answer set. And for this, let us start with B, 3, 4, 5, 6. Then I'll write elements of C and take care of the repetition. So I'll not write 5, 6 again. And then elements of set D. Again, you need to avoid the repetition. So write 9, 10 here. So this is the answer. I hope this question was very easy for you. If you have listened to the introduction lecture very carefully. Now this is intersection of the sets given in question 1. We have already taken care of this question while doing the question number 1, right? Look at these sets, set A, set B, set C and set D. A intersection B. So I'll write it very quickly. I just need common elements of set A and B. So 7, 9 and 11 are common to both. B intersection C. So what are the common elements of B and C? 11, 13. A intersection C intersection D. So common elements of these three sets. Which is the smallest set? D. So it will be out of these elements only, which are common to all these three. So 15 is common to C, but it is not common to A, right? 17 is not common with these three, so there is nothing. So let us leave it empty. This is empty set, or you can write it as 5. Now A intersection C, common elements of set A and set C. Set C has got 11, 13 and 15, and set A has got 11 in common, so this will be my answer. B intersection D. So let me start with D because it has got less number of elements, so it will be easier for me to start with D. 15 and 17. Now has B got 15 or 17? Nothing. So empty set, or you can write it as 5. A intersection B union C. So let me see B union C first. What is B union C? 7, 9, 11, 13, 15. So let me write B union C first. 7, 9, 11, 13, 15. Right? And now look at A. What is common with A and this set? 7, 9 and 11 are common. So this set will give me 7, 9, 11. And what are the other sets that are remaining? A intersection D. 15, 17 are there in D, which is not present in A. So it will be an empty set. So you can write it like this or like this. This one, B union D. So B union D will give you 7, 9, 11, 13, 15 and 17. And when you take intersection with A, 7, 9, 11 will be common, right? 7, 9, 11 are common elements. And this one, A intersection B, and then I'll take intersection with B union C. So let me write A intersection B first. A intersection B will give me 7, 9, 11. And then I'll take intersection with B union C. So which is 7, 9, 11, 13, 15. Right? Now what is common in these two sets? 9 and 11. 7, 9 and 11. So your answer will be 7, 9, 11. Answer for this one. Alright. A union D. A union D means 3, 5, 7, 9, 11 and then elements of set D, 15 and 17. Right? And then you need B union C. B union C will give you 7, 9, 11, 13 and 15. Now if you want to take their intersection, let us say, it will give you 7, 9, 11 and 15. So 7, 9, 11, 15. Right? And what about if I want their union? If let us say there is union here, then I'll take all the elements that are there and in this avoiding the common elements. Okay, so this was for intersection only. In intersection I took only the common elements 7, 9, 11 and 15. Alright, so let us look at the 7th question here. A intersection B. Let me do this question very quickly. A intersection B. Here x is a natural number, here it is an even natural number. So what will be common? Even natural number. So I can write A intersection B is B itself, right? Because this is a subset of A, because B is a subset of A. So what will be answer for your intersection? The subset. A intersection C. X is an odd natural number and X is a natural number. So obviously in this C is a subset of A. So your answer for this will be set C. Right? A intersection D. X is a prime number. Prime numbers are obviously natural numbers. So D is a subset of A. Hence this answer will be D. B intersection C. Even natural numbers, odd natural numbers, there will be nothing in common, right? Nothing, there is no number which is even as well as odd. So answer is empty set. B intersection D, even natural number and a prime number. So there is a number which is even as well as prime, that is this number 2. C intersection D, odd natural numbers and prime numbers. There are, you know, every other prime number apart from this 2 is an odd natural number, right? Every other prime number apart from 2 is odd, right? So how do we write? We'll write this in set builder form, that x is an odd prime number, right? Which of the following pairs of sets are disjoint, that have nothing in common? So x is a natural number and x is greater than equal 4, less than equal 6. So this, okay, this set in roster form can be written like this: 4, 5, 6, right? And this set has got 4 in it, so there is something common, so they are not disjoint. In these two I can see that E is common, so these are also not disjoint. Now look at this, this is an even integer, this is an odd integer, these are of course disjoint because these have nothing in common. Look at this one, set A is this, B, C and D are given. Now first thing that I am looking for is A minus B. So I am looking for all the elements that are there in A but not in B. So 3 is there in A but not in B. 6 is such an element. 9 is there in A but not in B. 12 is there in A as well as in B, so it will not be taken. 15 can be taken. 18 will be taken. 21 will be taken. A minus C. So elements that are there in A but not in C. So 3, 6 cannot be taken. 9, 12 is there in C. 15 is not in C. 18 and 21. A minus D. So 3, 6, 9, 12, 15 is there in D, so I will not take 15. 18 I will take and 21 I will take. So I am looking at elements of A, right? And I look at each element of A and then check it whether it is in D or not. If it is there in D, so I will not write it in my answer, right? Similarly, you can do rest of these yourself, okay? Following the same process, that for example for D minus C, I'll look at the elements of D. It should be there in D but not in C. So let us look at let us write this one. If let us say I look at the elements of D, I'll look at first element 5 and then I'll check whether it is there in C or not. It is not there in C, so 5 is an acceptable element. 10 is there in C, so I'll not write 10 here. 15 is not there in C, so I'll write 15 here. 20 is not there in C, so I'll write 20 here. So this is my answer, okay? So this is how we will do this one. Now I have got these questions which are very simple questions, so I'll do them very fast. X has got these elements, Y has got these elements, X minus Y. So I'll have elements of X that are not there in Y. So A is there in X but not there in Y. B is there in Y, so I'll not write it. C is not there in Y. D is there in Y, so I'll not write it. So this is my set. Y minus X. So F is in Y but not in X. B is there in X. D is there in X. So G is there in Y but not in X. Let me write the intersection of X and Y. What are the common elements? B is common and D is common. So this is X intersection Y. R is a set of real numbers, okay? Q is a set of rational numbers. So what is R minus Q? So R minus Q, right? Subtraction or difference of sets. So it means I need all the real numbers that are not rational. So what are these numbers? What are these numbers? These are irrational numbers. Irrational numbers. So if I want to write it in form of a set, because difference of sets is also a set, so let me write it in set builder form. X says that X is an irrational number. X is an irrational number. Okay, because real numbers consist of rational and irrational numbers. Okay, so and rational and irrational numbers collectively are called real numbers. If I take all the rational numbers, all the irrational numbers, that will give me my entire number line. Okay, state whether each of the following statement is true or false. Let us do it very quickly. These are disjoint sets. So if there is something in common, yes, 3 is in common, so these are not disjoint, so this is a false statement. These are disjoint? No, because A is common in both, so it is also a false statement. These are disjoint or not? 2, 6, 10, 14. 2, 6, 10, 14 are not there, so it is a true statement because there is nothing in common. 2, 6, 10, 3, 7, 11. So yes, it is also a true statement because there is nothing in common between these two sets. Okay, so this was about this exercise. Thank you.